My name is Steve. Welcome to my shop. Well, today I'm going to work on a project that has been on my list for quite a long time. And I finally put all the materials together. I've got them all laid out. I got my tools all laid out. And I'm going to start building a tapping fixture, a tapping machine. Recently, Mr. Pete built one from a casting that he put together, and I have a drill press base. This was from one of those cheap drill press fixtures that you can put a portable electric drill on, and it came in a lot of stuff that I purchased a long time ago. The holder on it was all plastic. I took that off and threw it away. But it's got a real nice cast iron base with slots in it. And it's got a 1-inch steel upright. So I'm going to use that for the basis of my tapping machine. I've got a piece of 1.5-inch square 6061 aluminum that I'm going to make the outrigger or the top for it. And I picked up a set of Lisle tap sockets, and this is what makes the whole thing really work. These tap sockets are 1/4-inch drive and 3/8 drive, so I'll be making up the shaft to accommodate that. I've drawn up a sketch. I've got all my tools laid out, so let's get started. As with most projects, I'm going to start at the bandsaw. Off camera, I scribed up the part, and now I've got my wiggler in there to locate the center of the hole. I've already got the piece centered up in the y-axis, so now I just have to center up the piece in the x-axis. Okay, I'm a little bit off. There we go. Okay, that's good. Using a 5/16 drill to run a pilot hole through. This is going to be drilled out to 1/2 inch. travel. These are stubby length drills. I'm going to put a full length drill in, and I'll bring you back when I'm finished. I just put a full length, jobber length drill in there, and I think that that'll be enough to get through. Okay. Now I'm going to drill it out to 1/2 inch. Originally I thought I'd ream it to half, but that's going to end up being too tight. So I'm hoping that the drill will run just a little bit oversized and give me a looser fit. No, I'm going to have to, let's see if the reamer will take anything out. Just got to loosen that up a little bit. I'll just lap it a little bit. It's really close. Now I'm going to move it down to my 1-inch hole, and that's 5 inches on center, so I'm just going to use my DRO to run it down. Okay, lock it in place. Okay, I'm getting close to my finished size. I'm going to go about another 10 thousandths. That just might do it. I want to leave it between 5 and 10 thousandths oversize. Okay, I'm going to move it out of the way so that I can get a better measurement on it. Measuring it at 960 right now. I'm going to just double check myself with the bore gauge, telescoping bore gauge. I still got a little ways to go, on about 965 approximately. Bring it back to center on my DRO. When I bring my cutter back up, I just put a little pressure on it away from the cutting edge, and that's just enough to keep it from scoring the bore. Just put a little bit up on it, and just enough, there's enough spring in it that I don't score the bore coming out, because I got a pretty nice finish on that. And that could be the final. So I'm measuring 985, which is 5 thousandths over the nominal size that I measured the column. So at this point, I'm going to take my chances and remove this from the mill and go try it on for size. Deburred it. Perfect. Very good. Okay, back over to the mill to do some more cutting and drilling. I'm going to cut a slot through here, across the center, and then I need to drill it and tap it for the locking bolt. I've got an 1/8 inch saw centered up, and now I'm going to try and cut my slot. Let's see how we make out. That's working pretty good, but it's going to take a while, so I'll bring you back when I'm a little closer to finished. Okay, I'm cut through the first section. Now I'm going to cut into the back of the hole. Go as far as I can. That's as far as I can go. Let's take it out of there and see how we made out. I was a little concerned that this might close up when I cut the slot in it, and it did just a little bit, but it's still a nice sliding fit, and I can actually lock it up just by gripping it with my hand. So I think that's going to work out great. Last thing that I need to do is drill and tap a hole for my locking lever there, and I'm going to drill and tap a 1/4 20 on the end to secure the spindle. I'm going to drill all the way through with a size F drill, which is the tap drill size for 5/16 18 thread. Now I'm going to change over with a clearance drill for the 5/16 thread, and that'll go through half so that there'll be a clearance for the 5/16. Perfect. So now I'll tap the 5/16. But I really don't need a guide for this because the clearance hole will keep the tap straight. But if I was trying to tap this, I do not have a point, a recess on it for a tap follower. And say in this particular case, the part itself is guiding me straight. There we go. Okay, very good. Just clean up the threads, deburr it, and the last thing that I need to do on this piece is to drill and tap the end for 1/4 20. I'm all set up to drill my tap drill for the 1/4 20, which is a number 7 drill. I'm using the flat face of the chuck to square up the tap. There we go. Got it started square. This is the set screw that I'm using. It's nylon, and now I'm using that to hold tension on the spindle. So I may have to cut it off a little bit. It's a little long. That works nice. Now we'll start making the spindle. I'm using my small diameter hone. It's a small diameter brake hone. We'll go down to 1/2 inch to hone out this hole. There we go. Almost there. Well, just a little bit more clearance. It's tight on that side. I must have a burr on that edge. I'm going to use my Noga deburring tool. Almost there. Gotta clean it out, gotta clean the grit out of the hole. Perfect. Beautiful. Nice sliding fit. And then this nylon screw will hold it in position. Absolutely perfect. Let's go put it together and see what it looks like. There it is, all assembled. And all I've got left to do is to make the spindle for it. When I started this project, I expected that it would be just one video, one and done. But it's become clear to me that it would be much too long to run this in one video. So I'm going to call it. This will be the end of part 1 of my tapping fixture build. In part 2, we'll finish up and build the spindle, and I'll show you how it works. Thanks for watching, and I'll see you in the next video.